In the context of this video, we will review writing and balancing chemical reactions, primarily the balancing component of the chemical reactions. Keep in mind that you should always balance hydrogen and oxygen last. In this first example, you don't have hydrogen and oxygen, so you don't need to worry about that. And also, you can treat your polyatomic ions as groups. Your coefficients are the only thing that changes when you're balancing. So there's a little bit of trial and error that comes with the balancing of chemical reactions. So we might have to erase along the way, so be patient as you're working through these problems. So first, we have 2 silver on the left. To get 2 silver on the right, we can put a coefficient of 2 in front of the silver on the right. Remember, the arrow, we treat that as if it's an equal sign. So we treat that as an equal sign. So now we have the silvers balanced, but I have 1 sulfur on the left and 8 on the right. So if I put a coefficient of 8 here in front of Ag2S, that messes up my silvers, but balances the sulfur. So I'm going to have to go back and erase. So 8 times 2 gives me 16 on the silvers. So I can go back now and put a 16 in front of the Ag. I think it's balanced now. Let's double check our work. 8 times 2 is 16 silvers on the left, 16 silvers on the right, 8 sulfurs on the left, 8 sulfurs on the right. So that is now balanced. Let's try another one. If you want to try this one on your own, you can feel free to pause the video, try it, and then come back and join me to solve it. So remember, I said before, you start with the everything but hydrogen and oxygen, and you do those 2 last. So I have 1 carbon on the left, 1 carbon on the right, 4 hydrogens on the left. On the right hand side I only have 2. So 2, a coefficient of 2 would make 2 times 2, 4. So now I have 2 oxygens on the left. On the right I have 2 plus 2 oxygens. So I'm going to make it 2 on the left. I'm going to put a coefficient of 2. Let's double check our work. We have 1 carbon on each side, so carbon checks. On the left I have 4 hydrogens. On the right I have 2 times 2, which is 4 hydrogens, so hydrogen checks. On the left I have 2 times 2, which is 4 oxygens. On the right I have 2 plus 2, which is 4 oxygens, so the oxygens check also. In this next one, you can pause it if you want to and then rejoin me later. We have NaClO3 yields NaCl plus O2. So I have 1 NaCl on the left and 1 NaCl on the right, 1 Cl on the left, 1 Cl on the right. Remember, I did the things that were not hydrogen or oxygen first. Now I'm saving my oxygen for last. I have 3 oxygen on the left, but 2 on the right. I know that anything times 2 is going to be an even number, so I have to make the left side an even number. So I'm going to go ahead and put a coefficient of 2 there. 2 times 3 gives me 6 oxygens. So to get 6 oxygens on the right, I have to put a 3 here. So 3 times 2 gives me 6 oxygens. I have 2 NAs on the left. To get 2 NAs on the right now, I need to put a coefficient of 2. 2 Cl's on the left. To get a coefficient of 2 on the Cl, I have the 2 from the NaCl. So let's double check our work. So now we have 2 NAs on the left and 2 NAs on the right, so that checks. I have 2 Cl's on the left, 2 Cl's on the right, so that checks. 2 times 3 gives me 6 oxygens on the left, and then on the right, 3 times 2 gives me 6 oxygens, so that checks. Now this last one is a little bit tricky because it uses polyatomic ions. To make things easier for yourself, you can treat your polyatomic ion as a group. By that, I mean if I see NH4 on the left-hand side and on the right-hand side, I can treat it as a whole group. So on the left-hand side, I have 3 NH4s. On the right, I only have 1. So I can put a coefficient of 3 in front of NH4 and O3. On the left, I have 1 PO4, but on the right, I have 4. So I'm going to have to put a coefficient of 4 in front of the NH43 PO4. That makes this 4 times 3 because the 4 distributes to this 3. So that's now 12 NH4. So I know that over here that this is messed up. So I've got to go back and change that to 12. So if we then erase, and I would highly encourage you to use pencil for this if you're not already using one. So we're going to change this to a 12, coefficient of 12. So now we've balanced out the NH4s and the PO4s. On the left I have 1 lead. On the right I have 3 leads. So I'm going to put a coefficient of 3 in front of the lead. That makes 3 times 4 for my NO3s. 3 times 4 is 12 NO3s, and over here I have 12 NO3s because I have a coefficient of 12. So let's double check our work using a polyatomic ions as groups. So let's write out first what we have on both sides. We have NH4s on both sides. We have PO4s on both sides. We have lead on both sides, and we have NO3s on both sides. So on the left-hand side, I have 4 times 3 for the NH4s. That gives me 12 NH4s. On the right-hand side, I also have 12, so that checks. On the left-hand side, I have 4 PO4s. On the right, I have 4 PO4s, so that checks. On the left-hand side, I have 3 leads. On the right-hand side, I have 3 leads, so that checks. On the left-hand side, I have 3 times 4, which gives me 12 NO3s. On the right side, I have 12 NO3s, so that also checks.